So this is a Proteus software, and this is the circuit overview. Now let's take a look on each of our component. So the first one is the LM35 temperature sensor. So the function of this sensor is to provide a voltage that is directly proportional to the temperature in degrees Celsius. Then next one is our IC741 op-amp comparator. So in this circuit, it is used as a comparator here. So what it does, it will compare the output voltage of LM35 to a reference voltage. And for the reference voltage, we have set a potentiometer of 2K. So we used to, what we will do in this, we will set a reference voltage that the op-amp compares with the LM35 output voltage. For that, we have placed the potentiometer. The next one is R3 register, R1, R2, and R3. So R1 or R2 are register that will limit the current to the LEDs. And R3 is basically working as a voltage divider in the circuit. Then we have placed two LEDs. One is of green color and one is of red color. It will indicate some output in our circuit. And we have placed a buzzer that will signal when the temperature will rise up. We have connected two probes. One is on pin 2 of LM3510 sensor to measure the output voltage, and one is of reference voltage. And in the last, we have placed a ground and a multimeter over the buzzer to check the output voltage. Now we will run the circuit and see the simulation. So before starting the simulation, let me tell you a small concept which will help us to understand the simulation more properly. So there are two conditions on which our circuit is dependent. So let me tell you these conditions. The first condition is when my temperature is below the threshold, the output will remain low and my green LED will stays on indicating that it is a safe condition. So what I mean by that is that when my output voltage of my LM35 sensor is less than the reference voltage, my op-amp will stay low and the green LED will turn on, indicating that yes, this is a safe condition. The temperature is not exceeded. When I slowly, gradually increase the temperature by 1 or 2, there will be an instance where you can see that my input voltage of IC is greater than the reference voltage. At this case, my op-amp will turn on and my red LED will glow with uh, the activation of buzzer also. So this case also indicates that the temperature has exceeds its limit. It is and it will generate an alert signal. So let's start the simulation and see how the things happen. So here we go. Just a second. Okay. So we have started the simulation and you can see the output voltage of sensor is 0.27 and the reference is 0.39. Initially, my reference voltage is 0.39 and throughout my whole change in temperature, it will remain as it is. What will be changed is the output voltage. I mean, input voltage of the IC. Okay. So let me gradually increase the temperature. Yeah. As you can see, uh, voltage is also changing in the uh, positive input of the IC, but the reference voltage still remains the same 36, 37, 38, 39. Here you can see at 40 degrees Celsius of temperature. Uh, in this case, my input voltage is greater than the reference voltage of the IC. So At this moment, my op-amp turns on, which also glows my LED and turns on my buzzer. So there's a problem in my laptop due to which you will be not able to hear the sound of my buzzer. So that's why I've connected a voltmeter around the buzzer to let you ensure that the buzzer is working properly. So that's it. I hope you understand all the concepts regarding the schematic diagram, simulation, conditions that I have told you. What is the role of IC741 in this circuit? So that's it. Thanks for listening.